Number 2. Okay, next one. Okay, we have a different situation now. Okay, so we are given the pressure. Okay, we have a pressure of a confined gas of volume V and temperature T. Okay, so the pressure is given by the formula of P equal to KT over V. Okay, which means that the pressure is in terms of two variables, T and V. K is constant. Okay, the question is, so we highlight the question, find approximately the maximum percentage error. Okay, the maximum percentage error in pressure where there is error. So the error here is given in percentage form. Okay, that is a plus minus 0.4% for temperature and plus minus 0.9% for volume. So do you think, okay, if you look at the previous example, so this one asking for just a maximum error. So they provide you all the measurement, right? All the value of each variable. They give you the value of x, the value of y, and the value of z. Just a value x, y, and z, or so at least you know the value for specific variable. But in this case, as you can see here, there is no such information provided. So there is no the value for each variable. So there is no specific value of t, and there is no specific value of v. But they just give you this information, the function and also the error. That's it. And how can you find or calculate the dp after this? But the value is not, the value of t and v are not given. Okay, now that's the thing I want to explain here. There is a way. So there is a way to evaluate, to compute without even though the value of the t and the v are not given. Okay, so this, for me, this is a favorite question. Okay, favorite question. So now we just take out what is the information that we have. So we are given a function p equal to kt over v, and also we are given the error of the temperature. Okay, something about t. I'm not saying t equal to, but something about temperature. So the information provided to us is we have plus minus 0.4%. So plus minus, it can be positive, it can be increased or decreased, right? And similarly for the volume, something about the volume. So I'm not saying V equal to plus minus, okay? So something about volume. So we have plus minus 0.9%. Okay, so this is only the information that we have so far. Okay, now what is the question? So they ask us to get the maximum percentage error. Maximum percentage error of P. So how can you convert this into the symbol, mathematical symbol? So this one is actually, so maximum percentage error of P. So remember last time I give you the formula, percentage error. Okay, percentage error of the function z. So z, this one is general. So now we want to approximate, right? So we're using the total differential. df is a total differential. So by using the formula, we have df over z, or dz over z multiplied by 100. So this one in symbol. So in language, this is the percentage error of the function, whether f or z. There is no absolute, mean there is no maximum, but for maximum we have this. So this is the maximum percentage error. So for this one, when you convert into a symbol, so it looks like you have, because now you have p, right, not z or not f. So dp over p, okay, and then multiplied by 100%. So that one is, this one is percentage error. But since you are just interested on the positive value, you just want to get the maximum. So you just put the absolute sign. Okay. So that is the thing that you want to obtain. So your final answer should be in this form, something in percentage form. Okay. Okay, so since now okay, back to the information provided. Okay, so in this case, they said that error in temperature, error in volume. So you can eliminate the plus minus sign, because you might wonder whether I have to consider positive 0.4 or I have to consider negative 0.4. So in order for simplify our work, we can eliminate the plus minus sign by putting the just 0.4 plus minus, and you put the absolute sign. So you have 0.4%. Okay. So what is actually 0.4%? So you have to, instead of you just put t equal to 0.4, that is wrong, because the t is just a number. So t equal to 1, so that is okay. This just fair. T equal to 4. But if t equal to 0.4%, so it is not fair in terms of writing, right? Because the left side t is just a number, but your right side is in percentage form. So how can you make it synchronized between the t and the 0.4%? So you have to rewrite the t into a percentage form as well. Okay? So because of you put the absolute, so now your t is the maximum percentage error of t. So you have to convert this one. So how can you rewrite the t into a maximum percentage error of t? So you have to put dt over t, and because you deal with the maximum, and then put the absolute sign multiplied by 100%. Then you can equate that by 0.4%. So now it's fair. The left side is about the maximum percentage error, and also the right side also tells you this is the maximum percentage error after you put the absolute sign, isn't it? Am I right? Okay, so now so the thing that similarly for the volume, okay, that is for temperature. Also for the volume, you cannot put V equal to plus minus 0.9. So you have to put absolute sign for plus minus 0.9%. So this one becomes 0.9%. This is a maximum percentage error of the volume. So in symbol, what is a maximum percentage error? So dV, because now we are talking about volume, dV over V, put the absolute sign, multiplied by 100%, will give you 0.9%. Okay, so now this is the information that we have. So because after this, you need to use this. You need to use this. Okay, so now we look at our problem. So now you are finding the maximum percentage error of the pressure, which the pressure is related to the temperature and the volume. Okay, so now your first task is to obtain the dP, total differential for P. So you need to have dP first. So what is dP using the total differential? So you look at here, your P depends on T and V, right? So you have PT dt, right? So you can see that T, and you have to put T. That is the, how can you memorize the total differential? Okay, plus, because it depends on two variables, so you have two terms. Okay, and P, V, D, V. Okay, so you can obtain PT, you can obtain PV by differentiating partially this one, right? Okay, now we obtain from here you want to get the partial derivative. So P T. So you differentiate P respect to T. So you have K over V. And then PV. So you can rewrite this to be this one as well. So when you differentiate P respect to V, so you will get minus K over minus KT over V squared. Okay, so now you plug in your PT K over V dt plus minus, okay, now you have negative, be careful. So you have KT over V squared dV. Okay, so I just put negative in the bracket. Alright. Okay, so can you evaluate the dP at the moment? Can you? You cannot. Okay, because you have no information about the V, the value of V itself. No, there is no information provided, right? Similarly, you have no information, the value of T. They just give you this one, but not the specific value of T and V. And similarly, you have no information about the changes or the error of the T itself. But the information provided to you in a percentage form, you cannot use this directly. Because this one is only for the changes, not the percentage changes, okay? Meaning that as for now, you cannot evaluate. So it's okay, you can proceed to the next. So what I mean by the proceed to the next level, so you just, because you want to obtain this one, right? Then you have to obtain the next level is dP over P. So now we go to the dP over P. dP over P. Which means that everything on your right here should be divided by the function of P. Okay. K over V dt plus KT over V squared dV divided by all the function for P here. KT over V. So now I want you to simplify the form because it took about how many layers? 4 layers, right? K over V divided by K of KT over V. So 4 layers. So now I want you to simplify this expression into only 2 layers. Okay, so because of this one is summation, right? Summation. So you can do the process. So let's say, so this one divided by this, which means that you have, okay, I just take out the first term, just because I want to simplify. So I have K dt over V divided by KT over V. So that is the first term. Okay, so that is the thing that I want to simplify. Okay, and the second one, you have plus. Now you have this one divided by this, right? Which means the second one will give you negative KT dV over V squared divided by KT over V. Okay, so now we want to simplify these two terms one by one. Okay, so the first one, so this becomes K dt. dt is in a group. Okay, you cannot separate d and the t. Okay, just dt in a group. So K dt over V and multiplied by V over KT. So when you simplify, V and V cancel out. K is free. Okay, just dt should be comes together, dt. Okay, you cannot separate d and the t. So you have K standalone, so can be cancelled. But you cannot. Okay, so now at the so far you have dt over t. But remember, dt is a one single thing. So you cannot separate. So please don't give me just d. So this is impossible. Okay, dt is a one single term. Okay, they are in a group. So you cannot do like that. So the thing that you can just simplify now, you can manage for the first term. For the first term, this one and divided by this, you will get dt over t. So then you can just copy your answer So now your answer here for the first term, so you have dt over t. Okay, plus, now we go to the second term. So now we simplify the second term. So here you can have minus kt dv v squared multiplied by v over kt. So kt cancel out, and you can simplify. V can be simplified. It's become 1 over v, right? So you have only negative dv over v. That is the second term. So now you put the second term here, negative dv over v. So that is for relative dp over p that you have so far. Okay, but from the formula you have to multiply by 100%, right? Okay. And because of your this is about the maximum, so it's okay, dp over p, and you put the absolute sign. So when you put the absolute sign, so you have dt over t plus negative dv over v, and you have that one, right? So I just put the 100% later. Okay, so now remember we have absolute, and when you have absolute, you have to split term by term. So this become dt over t absolute plus negative dv over v absolute. Then when you split them into each term, so it should be becomes less than and smaller, less than and equal to. So now you will have something like dt over t, okay, plus, so negative becomes positive, so you have dv over v. Okay, but since the information provided here, you cannot still use the 0.4 and 0.9 because that one is a percentage. So you have to make sure this one in a percentage form. So what you can do is just dp over p multiplied by 100% less than or equal to, so you have dt over t multiplied by 100%. So this one is already, we already apply the absolute, okay, plus dv over v multiplied by 100%. So can you have this value and also this value? So yes, you can. So where your dt over t multiplied by 100% is 0.4%. So we have 0.4% plus dv over v is 0.9%. So you will get 1.3%. So now your maximum percentage error of the pressure is smaller than and equal to 1.3%. So back to the question, obtain the maximum percentage error. So what you can say here from this inequality, you can say that therefore the maximum percentage error in P is what? 1.3%. That is your answer. Okay, so I know that you still confused, but since this is very important example and very important example, because I said that this is favorite question in the exam, right? Please redo this. Okay, please redo and do it one by one until you really fully understood. Okay, so the most important thing here is when you see the negative, you have to make sure you must provide me the positive. Okay, you have to make it positive. I mean that this part is very important. Okay, so imagine that if you've forgotten to split them. So if you've forgotten to split them, I'm sure that you will finally obtain to me, sorry. So dt over t. So you will give me 0. You will give me 0 0.4, 0 0.4, and you will give me negative 0 0.9. And your answer will be something impossible. You will get negative 0 0.5 or maybe just 0 0.5, where the answer here is wrong because you forgot to split the absolute into terms by terms. So make sure that all the terms, they are all positive. All right. So that is for the number 2 question.